Hey everybody, I'm back. Ooh, back from. Here we go. From this thing. Oh, this. Finger's still in the way. There we go. IBM Think, Goju, Gotchlick, Merle. There's a little. Sorry about the whatever that is. Yeah. By the way, super awesome conference. Thank you, IBM. IBM not only invited us to go to this, which we're super excited about, they hosted us. And so we got to meet a whole bunch of really cool people there, IBMers, non-IBMers, and we were demoing stuff. So we had like the Merle logo up, and Taylor and I were showing demos and things. Although, admittedly, Taylor was doing most of the heavy lifting, which he did brilliantly, I must say. And we met some fantastic folks from IBM. Really excited, just as an aside. I'm excited for all the stuff we're looking at with IBM, but there's one in particular that I don't know if I'm supposed to have a favorite, but I love the idea of potentially integrating Mentor and Merle Tech into some of the code assistants to level them up. I think they're doing some interesting stuff. I think they definitely have value, but I'm not a super fan of kind of like low fidelity code, as I think most of you Jeters know. And so we're in discussions now with IBM on could there be a path forward where we start to integrate some of the Merle tech into WCA, the watsonx Code Assistant, to where we try to improve its code quality. It's already quite good, as I understand. I know probably more technical details about it than I'm allowed to share, so I'll keep those things to myself. But I'm very impressed by some of the things that they're doing. I really like how one of the things I quite like about IBM is I feel like they're very responsible when it comes to the way they're approaching AI, and they've done certain things on the way that they've trained their watsonx Code Assistant, which feels very ethical, that some other folks that are doing code assistants are not doing. And in fact, at Merle, we followed very similar principles in training Mentor that IBM has taken. And I think perhaps the most curious piece is we had made these decisions independently of each other. So we had no idea that they were doing this. I don't think they knew that we were doing this. And then we started talking and we realized, oh, wow, we kind of made similar decisions here, which is cool. I think that because those decisions were done with ethics at the forefront of our minds, our respective minds. So I'm super excited about a number of new opportunities that we're looking at with IBM. And just in general, the IBM Think conference in Boston was super cool. The venue was really fantastic. This is our first time going to IBM Think. And we got invited to go last year, but we were just too busy. And so this year, Taylor and I went, and we were both super impressed by the quality of the venue. And there were, I think the estimates were there around 6,000 people, something like that, in total. I think maybe 2,000 IBM or something like that. And it was in I think the Heinz Convention Center, something like this. And yeah, it was just really well put together, really well organized. I caught a little bit of Arvind Krishna's keynote address. Arvind is the CEO of IBM. And in the part that I watched, he was talking about the two key areas of the future of IBM, which I absolutely love. One of them is AI. So obviously that one resonates with us really well, especially given that his interest and their interest is AI in many areas, but AI in code or machine programming as a central piece. Absolutely love that. And then the second area was quantum. And I don't really know that much about quantum. I have a lot of my scientists, friends, and researchers are experts in that space. And so they try to educate me, and mostly it just goes way over my head. But I do think quantum is a really interesting area to explore. And it's one of those things where if you understand the principles of cryptography and encryption and things like that, you probably have some awareness that a lot of the way that the algorithms work today is based on limitations that we have in traditional von Neumann computing architectures. In particular, their inability to find prime numbers that are very large in a computationally tractable way. And that's sort of a cornerstone to how we keep our systems secure. So there's a lot of discussion, as one might imagine, that if quantum becomes real and it reaches a level of ubiquity in terms of its adoption, quantum machines, at least from my naive, kind of clueless perspective, quantum machines don't inherently have a similar limitation as our current commodity compute systems in terms of their ability to identify prime numbers in these like really long temporal windows. So whether it's CPU, GPU, whatever, there's various different techniques on how to find these. But either if you're mining Bitcoin or you're just literally trying to walk a number and find various primes on like a CPU, regardless, it's something that can require some compute, some power. To the best of my knowledge, it's not something that we have the ability to handle in an extremely fast way. But with quantum being potentially around the corner, now we have something that could be a bit of a game changer. And so there's a lot of fear I think fear is probably right. Fear, anxiety, just general nervousness in the security community that if quantum becomes practical and becomes commodity, the entire infrastructure of all of our secure systems will essentially crumble. That essentially the bottom will fall out of this stuff. And like, what does that look like? How do we build secure systems? And again, not, I've the most I've done is built a couple encryption things, taken a couple grad classes. This is not my area, so I don't want to speak too much on this. But I'm super excited about quantum, largely because of the potential that one can have with quantum machines in terms of solving really hard program synthesis problems, especially doing really deep semantic or intentional reasoning on systems to then synthesize, in other words, generate large pieces of code. That part really excites me. On the other hand, I'm not super excited about the entire space of our secure systems suddenly potentially coming undone if these quantum systems become practical. So I guess the short of it is it'll be interesting to see how this unravels. We'll all stay tuned. But I just got back from Boston, and yeah, it's 11 p.m. I think I landed in SFO just a couple hours ago, and I missed all the Jeter so much. I actually did. It's getting kind of wacky how kind of, I don't want to say addicted, but how incentivized I am to be making daily vlogs. It's starting to become habitual. Like while I was at Boston, I didn't do any new content, but I was able to create like maybe another 20 shorts, which are cool. I'm not a super fan of the shorts, but if it gives us some awareness for people to then dive into like the longer videos, the ones that I actually think are the way to really learn and kind of embody the ideas that I'm striving toward with GTT. If that becomes a vehicle to get people to pay attention to the long form, then by all means, I'm totally down with that. But creating shorts, it kind of feels like I'm just carving up existing videos. It doesn't give me the same kind of meaningfulness hit that I get from creating new content and talking about exciting, fun stuff like IBM Think and some of the folks that we met there, the Watson X Code Assistant team, and other exciting stuff. Like I forgot that IBM has a number of different architectures, like in particular the Power architecture, which I think I did some parallel computing work on Power, mostly because their cache coherence protocol is like super relaxed. It's like more relaxed than I think I'm going to get this wrong, but like Intel's, it's not like total store order, like TSO, it's something else, I think. But that one's pretty relaxed, and it's used predominantly in industry. And I think that it kind of makes sense. Again, at some point we can look at what this looks like. It can be tricky if you don't understand data dependencies in programs, because things can appear to execute in a very non-intuitive, out-of-order way. But if you understand data dependencies in programs and how those have to be respected, it's actually, at least for me, it's not that complicated. So that's x86's, like, I don't think it's called total store order, but it's something like this. And this is a relaxed cache coherence protocol to essentially make on I'm going to try to say this the right way, to try to make multi-threaded programs that are running through synchronized shared memory correctly. And what that basically encompasses is usually what you're thinking about is single node multi-threaded programs that are executing multiple threads of execution, but they have some form of shared memory. And so they need to have data coherence between the multiple threads. That gets into the cache coherence piece. We could do, several months of discussion of computer architecture and how cache coherence is super important for von Neumann architectures when you're doing multi-thread programs, but we won't do that right now. That being said, I remember when I was learning about the x86 relaxed cache coherence and thought that was pretty cool. And then I started meandering as I do. And I don't think this is part of like a course or anything. I just started getting curious and I started reading up about the power architecture because I think it was coming out in like the PlayStation 3 or something like this. So let's just see. PlayStation 3 power architecture. Is this what it was? Yeah. Okay, so the PlayStation 3 uses a custom CPU architecture called the Cell Broadband Engine. This architecture combines a main processor, the power processing element PPE, with 8 synergistic processing elements SPEs. The PPE is a 3.2 gigahertz 64-bit dual-core CPU based on IBM's PowerPC 2.02 ISA instruction set architecture. This may sound like a whole bunch of Greek to non experts in computer science or computer architecture, but it's basically just saying that inside of the PlayStation 3, they were using hardware from IBM, and the hardware is this power architecture. So what's also interesting as an aside is, as I understand it, it did have 8 cores essentially, but I think there was some sort of notion that you should never code to more than 6 of the cores for some specific reason. Maybe somebody can Google this and drop a comment on what this all meant, like why you do that. Anyway, I remember hearing from some of my dev friends in gaming when they were developing for the PS3 that without like a PhD in cache coherence or computer architecture, and again, keep in mind, my graduate degrees are actually computer engineering. And even for me, like I remember trying to understand the relaxed nature of the cache coherence protocol for the power. And I remember thinking, this is like hurting my brain trying to reason about this. And the reason why you generally have relaxed cache coherence protocols is you're trying to maximize the multi-threaded potential of these parallel programs. You're trying to essentially get as much performance as is possible while still only allowing like correct programs to execute, that the threads are going to get sort of like the right-ish data. And again, this is a very complicated thing. In case you want to get like a sense of it, just Google like eventual consistency, which is more of a distributed computing technique, but it'll, I think, kind of get your brain working on how this is challenging. Or then you can look at, you could Google something like relaxed cache coherence protocols for data dependence. And those should take you down sufficiently interesting tangents and discussions of why this is cool. Anyway, so while we were at IBM Think, we were talking with one of the heads of their various architectures, and there's an emerging opportunity to potentially work with some software systems that are running on IBM mainframes and IBM Power. And just the sort of inner nerd in me, when that came up, like I feel like I'm a kid at the candy store thinking, oh, this could be like, whether or not this, again, I've said this many times, I don't necessarily make the best decisions in life when it comes to business or, I don't know, money, those types of things because I'm very motivated by working on hard technical problems that I find fascinating. And that sometimes supersedes other things like practical value of these types of explorations. And so, given my position at Merle, I think I'm supposed to be far more responsible. But admittedly, I was getting pretty giddy. I even like derailed the conversation a little bit to talk about the power architecture to make sure I was understanding. So, anyway, good stuff. We'll see what happens. But if you see in the very near future that Merle is suddenly doing some really advanced stuff with power for IBM, you may know where it all started. Okay. One other thing that I wanted to share is I was just made aware earlier today, that the situation with NATS and CNCF seems to have been at least partially resolved-ish. And so I wanted to kind of take us through this a little bit. And this goes back to this this vlog that I did 9 days ago. And here I'm talking basically about the challenges that CNCF and NATS are kind of experiencing with NATS looking to kind of break away from CNCF. And I shared my thoughts on how I don't know that this is necessarily like that good of a decision. And it's not clear to me if this is even legal, all of this type of stuff. So I did, I think, share in, I think, what I attempted to present as a pretty fair argument on why I think NATS trying to break away from CNCF is not a super great decision, and that there are potential consequences. Also, I'm not even clear if it's actually legal. And so my take on this video, just for those of you who didn't see it, is I'm kind of siding with CNCF, that I think that they're doing kind of the nothing wrong. They're kind of like doing nothing wrong. And NATS is kind of pushing the boundaries on what might be considered, pretty not great behavior. We'll maybe leave it at that. So I found out that we actually have some kind of alignment on this now. So I wanted to quickly take us through this. This was May 1st, so just a few days ago. I feel like maybe I'm just really slow on this. Hey, you coming up here, buddy? Okay, come on. Come on, buddy. Come on. Merle wants to be part of the... Yeah, come on, show everybody that you're here. Here we go. Okay, there we go. Okay. Merle's gonna... he went into full crazy mode once I got home. He was letting me know, never leave me again, Daddy. Ever, ever, ever. Yeah, it's like I was gone for like 2 days. He thinks it's like 2 years. It's pretty sweet. And he collectively emptied all the trash in the house and looked for all the goodies. So there was some cleanup time. It's amazing that I'm even getting to a podcast tonight. But small footsteps every day, right? Like I'm trying to live it. So anyway, just to give a quick catch up on this. This is on CNCF's website. CNCF and Synadia, if that's how you say it, align on securing the future of the Nats.io project. Okay. Cloud Native Computing Foundation, which builds sustainable ecosystems for cloud native software and leading edge innovator. Synadia today announced widely adopted Nats project will continue to thrive in the cloud native open source ecosystem of the CNCF with Synadia's support, continued support and involvement. Cool. That's great. The agreement comes following productive discussions with Synadia about the future of the NATS project to align expectations and reinforce open governance. Synadia has agreed to assign its 2 NATS trademark registrations to the Linux Foundation. These steps further secure the project's neutral stewardship for the future. The NATS project's infrastructure and assets, including the nats.io domain name and GitHub repositories, will continue to be held by the CNCF, ensuring long-term stability and ongoing open source development under the Apache 2.0 license. As stewards of the NATS project, CNCF is committed to upholding open collaboration, neutral governance, and shared ownership so NATS can continue to grow and thrive as a community-driven project, said Todd Moore, SVP Community Operations, the Linux Foundation. We value all of Synadia's efforts in developing and contributing to NATS, including their investment in defense of NATS trademark, and appreciate their continued support of the project. Okay. And then we could continue to read all this, but we'll skip that for now. I'll probably just drop this link in the comments so everyone can read this in more detail if they're interested. But I wanted to just follow up and say that I'm like very pleasantly surprised. I got to be honest. Even though I really do try to foster goodwill, and in my vlog, I was trying to foster goodwill for Synadia and Derek and their other contributors who, again, I don't know these folks, but I suspect that they're probably good people and just may have some conflicting motivations, which can happen. You know, that's totally understandable. And I was, I think, encouraging them to potentially revisit this in that video. And I think I said something like, I'm not sure. I think that this isn't too far along where this can't be reversed. It's my hope that it's not to a stage where this can't be walked back and fixed. And so, and truthfully, I didn't know. It seemed as though it was still early and emotions were pretty heightened. So it made me think that maybe there's a way. But I wasn't actually, again, just being honest, I wasn't thinking that this would actually happen, that they would be able to come to the table and compromise and find sort of an elegant way to navigate through this from both parties. And so this actually really, I'm delighted to see this. And I think it's maybe another really good example for us Jeters about how fostering goodwill and really not resigning ourselves to negativity or doubting people just because something initially isn't looking so super good, giving people the benefit of the doubt and still kind of rallying for them, I think can be really helpful, right? In some sense, I think I could have done a vlog where I was really critical of Synadia and Derek and said things that maybe I'd feel really embarrassed about right now, knowing the outcome here. And I haven't rewatched that video, but if I recall correctly, I think I was pretty careful to not say anything really bad about Derek, principally because I truthfully didn't know. And I do foster goodwill, and I can put myself in his shoes without knowing him and think, yeah, I've been pressured by my investors to being pressured by my investors right now to do certain things that, you know, maybe I'll do, maybe I won't do. I guess we'll see. But this, I think, is one of the benefits, which is like sort of a real-time example of the good things that can come out of fostering goodwill, having this stewardship of positivity rather than negativity, and how that kind of attitude can maybe raise all boats. And I was contacted by some of the folks at CNCF, and I think they had seen that video. It's, I guess, been making its rounds, and so that's cool. I mean, I don't think that my vlog had anything to do with the outcome here, but I think that it is super cool to see this type of thing happen, and to be able to look back on how all of us thought about this and try to be community members that are positive and fighting for, good outcomes rather than resigning ourselves to failure and negativity. Anyway, I just wanted to share that with all of you. Somehow I wasn't looped in to see this earlier. Trying to figure out how. Oh yeah, I guess I was just super backlogged with stuff related to the IBM Think stuff. So that's part of the reason why maybe I'm a little slow on the uptake. But anyway, that's basically all I really wanted to talk about in this episode. I wanted to just hop back on real quick to say hi to everybody, and super pumped to be back. I have some really interesting content that I'm excited to share. There's one in particular that I'm going to show the advantages and the power of Mentor's deterministic AI compared to other stochastic language model stuff. And yeah, I can't wait to do that one. I actually did a little homework and got a couple things aligned to try to make sure that the story is more compelling than just sort of an impromptu vlog like I would normally do. So anyway, I hope everybody's having a great week. I'm super pumped to be back in NorCal. Boston was great. The IBM Think event was super fantastic. Again, thanks IBM so much for hosting us and spotlighting Merle. We've received a ton of feedback from IBMers as well as other companies that were there. And, thank you. It was super cool to see the Merle mascot like floating around in various places. That was pretty awesome. And with that, I think we'll close this out and stay tuned for the next one, where we might get a little bit deeper into some of this crazy stochastic and deterministic machine programming stuff.